Okay. So, we have a really small class today. Okay, before I start the lecture, let me have it uploaded so I'll be sure it's here. Okay, any questions or comments, concerns, anything? Okay, so in order to have like more structure and for you guys to remember, I'm going to have the makeups next Friday, so you have like 1 week to study, and then if you still want to, schedule tutoring sessions with me, feel free to do so. And I try my best to be available, accessible, accommodating, all those good things. And for makeup quiz 3, just email me. For makeup quiz 3, just email me and tell me when you want to take it, and then I make sure to program Canvas so it would be available for you when you want to take it. So this is online. We're not worrying too much about it in the sense of arrangement. But for in-person makeup, exam 2, right? I'm going to have it next Friday, which is April 15, in the evening. So after 3 p.m. So you're welcome to have it like 3 to 4 or 4 to 5 or 5 to 6. Anyone is in this classroom that they want to take makeup exam 2, but any of these times don't work for them. Okay, what time works for you?
I'm going to be gone.
Okay, did you already email me?
Yeah.
Okay, so we're all set. Okay, so if it doesn't work for you except her, anybody else? And if it wouldn't work for you or you realize you have some obligation at that time, just email me, we figure something out. But if I just want to schedule individually for everyone, it's not feasible for me. So that's how I do it. Any questions, concerns? Are we clear on the exam, makeup exam 2? Okay, so you'll be having your next quiz due on this day too. But again, this is makeup, so I cannot change the structure of the course entirely because of makeup. Okay. And I'm going to try to write your quiz this weekend as well. So anytime that you see the quiz on Canvas, it means that you can just answer the questions based on the information that you have in the class. I won't do the thing that I did first time. So if you see quiz 4, feel free to take it if you studied the materials. Okay, so this is all the housekeeping stuff in a sense. Any questions? Good. Okay. I'm not going to, so I'll also talk about during the next class. Any questions? We have 38 people in our class. Thank you. Thanks. I'll come back to attendance last, so let me first progress with the lecture. So I was telling you each session that what is a slide. This slide is not good, and I also included those. Let me go. This morning I thought, okay, let me show you what a good slide is. So a good slide should have like information, should have a title for your reader to know what we're talking about. And then I included the part of the book that I'm talking about, because as you may have noticed, I'm not covering everything in the book because we don't have the time and there's no need to go in too much detail. I prefer for you to have like general knowledge of everything. So for the first 3 chapters or like 2 chapters, I was like more thorough because I wanted you to know the concepts. But after that, we talked about, okay, what is alkene, what is alkane, what is benzene, what is what are aromatic compounds, and kind of like I'm going to do the same. And then next chapter that I'm covering, I'm going to talk about alcohols and all that. So that's why I write the section that I'm teaching, so you know which part to study. Okay, and if you go to some parts of the book that you have no idea what's going on, and you came to the class, you know what's happening. So it means that I'm not going to ask that in the exam. Okay, and when I write the next study guide for your next exam, I'm going to emphasize these parts of the book. So you have like a better understanding of what I'm covering. So we talked about benzene ring and aromatic compounds, right? And aromatic compounds are compounds that they have a benzene ring. Now we want to talk about polycyclic aromatic hydrocarbons. So what do you think polycyclic means based on the name? Exactly, it has multiple cycles, it has multiple rings attached to each other. Okay, and in the next slide I tell you what is the difference, or like what is the difference between benzene ring with substituents or different aromatic compounds that we studied before. So your book has like the text, and I included that for you guys too, to make sure that you study that, because it has lots of things that I'm going to ask you in your homework, exam, and all that. But I thought it's like good demonstration here what your book was saying just with text. So if we want to produce steel, and I talk about that in more detail in my 101 class, what is, matter consists of mixtures, pure substances, and one example of mixtures are alloys, right? And alloys is like when we mix different metals with each other. And one thing that is a mixture is a steel, right? And production of steel involves mixing coke with iron, okay? And you may think, okay, what is coke? Is it like a drug, or like, is it Pepsi? What is it? So there are like different contexts that when we talk about coke, even when I was just like wanted to find pictures on the internet and all that, if different things, interesting things would come up. So you can do that to see too. Anyway, so you accept from me that when we mix coke and iron, we get steel. And this process needs lots of heat to mix these two together. You see like different types of steels, right? Like stainless steel, we use it as some part of it, or pots or pans are made of that. And this is like really important, it has lots of applications and all that. But what is coke? If we have coal, and coal is some sort of fuel, right? We heard of gas, coal, those things, right? If we heat that without air, in the absence of air, we can produce coke. And most of the reactions that we have in industry, they have byproducts. There are things that we don't want. And one example that we talked about in class before was like combustion reactions, right? So technically, when we have hydrocarbons plus oxygen, if we have complete burning or combustion, we get CO2H2O. But most of the time, we get like CO. So this is one byproduct. This is not what we wanted, but we get it. So byproducts are things that we don't necessarily want them, or it's not the purpose of what we want to produce, but they will be there regardless. And sometimes in some reactions, we actually want the byproduct, right? We take advantage of this byproduct. We design reactions somehow that we get more of the byproduct. And we talked about reactions a little, like thermodynamics of reactions or kinetics. So I wanted you to have like some overview, some understanding of reactions, but this is not the main purpose of our course. So one of the byproducts would be coal tar. Okay. And the reason that I talked about all this is to focus on coal tar. And this here between polycyclic aromatic hydrocarbons and coal tar, as I and this is slide that, and I included the text so it would be easier to study for you. I asked from that, and then I expect you to know an example of, a substance that has an example of polycyclic aromatic hydrocarbon called coal tar. So the substance has several different substituents, or rather, it has several different rings in its structure, right? And then I wanted to give you an idea of how big the substance is and how so many substituents it has. So I refer to this paper here that I cited, so you are welcome to just go look at it too to have like an understanding. But it has, for instance, xylene. Can anyone tell me what was xylene? And I told you that I expect you to know. Yes? Three, yes. We had three methyl, 3CH3 attached to the benzene ring. We had like xylene, we have toluene, we have like, what else we have? We have like all sorts of, compounds in this, cold. Specifically, we have in this structure, okay? So the ones that we studied before, as mentioned, is an example of polycyclic aromatic hydrocarbons. And this table that I included you, so this one, but I'm not going to ask this table from you. Just knowing that there are so many things going on in coal tar and it has like different rings in it. Okay, naming of this slide. And this is the continuation of that table. It wouldn't fit in one slide, so I have it like here. We have like phenyl, all sorts of, So this is like a really big structure, and scientists go to laboratory, and you can, kind of look at this paper to see what I mean. To see, there are like scientists trying to just investigate what rings this substance has, or like what, compound. Not a good. This is kind of like your book, as I said, wants to demonstrate the purpose of what we're studying, okay? And we have like something named naphthalene. Have you ever heard of naphthalene? Have you ever heard of mothballs? Have you ever seen like holes in your clothes and like what happened here, Then there are like some clothes that moths like more, I had like moths in my previous apartment in New Hampshire, and then I was just like fighting them, and then I was like, and I didn't want to have like pesticide or like, I don't know, mothballs, because these are, if you get mothball, it has like this long instruction that, you should have like one small piece in a really big room because it can be, intoxicating. And I'm like, I don't want to worry about it. I had a really small apartment, so I should have like broken that down. Anyway, so mothballs that we use to protect ourselves from moths, or specifically our clothes, because they like those more, consist of naphthalenes. Okay, and naphthalene is basically two benzene rings kind of fused to each other. So this is the difference with substituents. When we had substituents, we had a benzene ring, right? And then we had something here like chlorine or methyl, right? Or like any substituents that we had. Or even we could have like one benzene ring here, right? And then another one, attached to it right here. Okay, I should change my, right? Even this, as you see, these two carbons, are not, so these two cycles or rings are not fused with each other. So this is the difference between, does that make sense? So now, going back to naphthalene structure, again, we have like two benzene rings, we fuse them together, and here the bond length, do you remember that when I only had one benzene ring, I told you that I write double bond and then single bond, but all of these bonds are the same, and all of them are something intermediate between double bond, single bond, remember? In this case, when I have naphthalene structure, these bonds, actually the bond lengths are different, so they're not the same number, and the number for benzene is like 1.39 angstrom, and as you remember, angstrom is 10 to the power of minus 10 meter, and the reason we use that is, depending on what we're dealing with, we have like the appropriate unit, right? That's why we don't use kilogram for one atom, we use atomic mass unit. The same thing here, because these bond lengths are really, really small, 10 to the power of minus 10. You see that this number is basically this. And then we have like 10 zeros. So instead of writing that, we write angstrom. And I'm not going to ask you what is the bond length, just knowing that these numbers here are different. So we have like different bond lengths in naphthalene. And here, again, your book relates the naphthalene to coal tar that talked about. That naphthalene was the first compound to be obtained from the higher boiling fractions of coal tar. So this is kind of like the connection of what I just said before to this one. But naphthalene, I expect you to know the structure and the following things that I'm going to tell about it. So let me have this here as your reference and write this here myself. So let's, instead of, I have like the answer kind of there, but it's nice also to walk through this together. Okay, so if I tell you I want to add one Br atom to this structure, okay, I say one Br atom. How many possibilities do you think it can be? Or let me, so let me, and I use the same numbering system that your book did so I don't confuse you with my numbering. And then for these two, it uses 4A. Then for this one, it uses 8A. So can anyone tell me one possibility that I attach one Br atom to this structure? Where should I attach it? To which carbon? Anyone? Just
1 and 2.
Okay. So if I put it here, right, this is certainly one possibility. And if I put it here, and maybe it's better I change the color. Okay. If I don't blind you with this color, BR, okay. I was telling your friend that I was looking, for cool colors to use, but most of them, I don't know, are not that cool. I want that to not to be that annoying or like hurting your eye, but kind of distinguish it. So I want like cool green, but this is the best one that is I can find. Anyway, so these two structures are different, right? Can anyone see that? But what about this one? So these two blue ones, do you think these two are distinct? If I just get one of them, for instance, this one, the other one that I didn't erase, right? And then if I just, flip my molecule the other way, right, I get the other one, right? So that's why these two are the same. What about this one compared to the one that I attached to carbon number 1? Do you think these two are distinct? No, right? If I kind of, again, flip my molecule the other way, and then again do this, basically just by rotating or like changing the place of your paper, doing some like flipping around, you can get the same thing. And this is the same thing with this one, okay? So all these 4 are the same. And that is what your book wrote here, much nicer than what I did with these numbers here. It has all of them with blue, meaning that these are like the same. Wherever you attach some substituent to it, doesn't matter. But here, again, the same story here. If I have the Br here, or here, or here, or here, by the same rationale, if I just like kind of rotate the molecule or like the piece of paper that I'm writing on or like my iPad, I can get the other structure. So these ones are not distinct either. Okay. Do I have any other place to attach Br? So let me see. If I attach, I use the indigo one. So if I attach, can I attach the Br here?
Use the other double bond.
Oh. So if I attach it here, remember that we don't do the conventional thing that we were doing in alkenes to get rid of double bond, right? So we keep it, and then we did the same thing here, right? I didn't change anything. I just added, this Br here, or like rather substituted that with hydrogen. It was hydrogen before. I just get rid of hydrogen, added Br. So if I do this here, what would be the valence of carbon here? Or how many bonds does it have right now? So that is not a possibility, okay? And we remember lots of things for exam, but some stuff you can just like write the structure and then see if it makes sense or not, okay? Okay. Just agree based on your book nomenclature that if you have, so you start from like here, one top, and of course, if you start like for instance from, if you don't have any substituents, you're welcome to start one from here, for instance, or somewhere else, because again, if we flip the molecule, we get the same structure. But when you have the substituent, you, depending on, for instance, we try to have like the lowest number for the substituent, right? But regardless, we call this one 1, 2, 3, 4, 5, 6, 7, 8. Just like these numbers, remember this, okay? But what I mean is that if you have like your substituent here, you start naming 1 from here. Does that make sense? But again, if you have here, it would be 2. Is it clear what I'm saying? So it's not like your substituent is always 1. Your substituent has the lowest number with this numbering system, which starts from here, 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 okay? And we don't go in too much detail naming these compounds. So just few examples that I give you in the class would be enough for your exam, okay? So that's going this naming system, numbering system again. So now we have really similar reactions as what we talked about last session, electrophilic substitution reactions that we had before, and I also basically we do the same thing that we did before. It's really similar. For instance, if we have like, if we add HNO3, and now here basically is the same. But if you want to write this reaction, what your book did is to just gave you that if this reaction occurs, there are like 2 different possibilities. And this is what I asked you in your exam. How many monobromination products is possible when cyclopentane reacts with bromine molecule? Remember those types of questions, you see that how many isomers are possible. So if you want to write the complete reaction here, or like you have like this naphthalene, and remember to alternate this double bonds. And then if that is plus HNO3, and remember in previous chapter 2, we said that sometimes scientists would save time, instead of writing our compound plus Cl2, they write Cl2 on the arrow, right? And then they just write the organic product, not inorganic. So this is what your book did here, but I'm going to write the complete version in case there is any confusion. So now I told you to remember, if you have nitration, the product should be water, right? So if here I want to write water, I know that this hydrogen that I have here, for instance, and you're welcome to choose this one, right? Or this one or that one. Any of them work. So don't stress too much about which one. And then I know that I should get one OH or HO out of it, so I have like NO2. I kind of check afterwards HNO3, so that makes sense. Okay, and this is like at this specific temperature. You don't have to, worry about that. Everything that you need to know. I never asked you to remember a temperature or like a bond length. I mean, the only thing that I asked you to remember was like 109.5 degree, the angle between, in molecules, or like 120. But other than that, you don't have to worry about temperature, for instance, that what it is. You should have like a, understanding. Is it like low temperature? Is it high temperature and all that? But more than that, you don't need to know. Okay, so going back here, as I said, I kind of switch these NO2 with this one. So how I write this, I have the same structure here, and as you see, I cannot do a good job writing the same thing. It's just distorted, but let me try to do better. Like this, a little better. So here I attach NO2 here, and I already wrote H2O here. And what do we call this molecule? So the name is naphthalene, and we have a nitro group, so we write nitro naphthalene. And the way to know what number is this, why we call this 1 nitro naphthalene. So what I do in exam, at this point you saw like your exam 2 and also different versions. I encourage you to read all the versions, and most of them are like the same questions. I just change the numbers if they're not exactly the same question. But the ones that I hand wrote, they are slightly different. So at least look at the ones that I did handwrite. So what I do is that I give you this and I say what is the product of this reaction. And if you have an idea of the class and then come to the class just paying attention, you just remember she said we have water, and then here the only thing that you can substitute or like is more intuitive is like nitro NO2, and we have so this is would be easy for you to answer. But what I do, I separate these two benzene rings, give it as one option, or like turn double bonds to single bonds, or write addition reaction. So in that case it could get tricky, and I always tell students that come to my office hours to answer the question. Don't look at the multiple choice questions, to options. Just answer the question yourself and then check your answer, because sometimes you know the answer but you see something and it seems correct and then you get tricked. Does that make sense? Okay, any question about this? Good. And what you can do is that you write exactly the same thing, and I try to do that quickly but not too terrible. If you do the same thing, you can have really similar structure, but you can attach this NO2 instead of here, you can attach it here. Okay, exactly the same procedure and all that. And what you write here, so what would be the name of this one? 2, exactly, nitro naphthalene. And then your book wrote it like this, but it assumes you know that what this means. You have water in each, so there are like 2 organic products possible when we have nitration of naphthalene. So that can be exact question that I asked you in exam. How many organic products are possible in nitration of naphthalene? And you see 2. And your book says that this one nitronaphthalene is produced in much more than the other ones, or the ratio of this compound to the other one is much more. It's basically 10 to 1. But again, I'm not going to ask that from you either, but you should know that they're not being produced the same quantity. Any questions? Good. Okay, and I apologize for the handwriting. I try to be fast, but sometimes I forget that it's not readable much. But I have like the text. That's why I include your textbook too. So I included the slide here to refresh your memory, right? That we had Cl2, and we said that here we have like hydrogens, right? Hydrogens, and what we do is that we kind of switch these guys. So I have chlorine attached here and then H attached to Cl, right? So nitration reaction, remember that how we do this, or I told you to remember that one of the products would be water. If you remember that, and then here you have nitric acid, and I don't ask you the name of the compound. Even in my 101 class, I didn't talk about naming acids. They didn't learn naming ionic or molecular anyway. So here, if you remember that you should have water here, you can extract, and then if you remember that here we have hydrogen, and then we switch something with hydrogen, right? So what should I have to react with hydrogen to produce water? Is the question clear what I'm asking? So I said, I want to give you hints or ways to write this structure in exam, right? What I'm telling you is that remember that when you have nitration, you should have water as your product, okay? And you know that the benzene ring has like this structure, and we know we have substitution reactions in benzenes, right? We don't have addition. And if I give you this HNO3, so if you know that water should be produced, right? And then if you know that you should substitute this hydrogen with something in this molecule, right? So my question is that H plus something gives me H2O. Can you tell me what is this one? OH, exactly. So what you do is that in your structure, you have like HNO3. If you get one OH out of it, or like HO, what remains is NO2, okay? So what you do, you know that H with OH gives you water, and this NO2 you switch with this hydrogen. And do you remember what did we call this? Nitro. Exactly, nitrobenzene. Okay. So what I explained now was kind of like just remembering how to write this reaction. Is it clear? Does that make sense? Remember, this is what we have here. This you have like a good source. And this was just a review. Let's tell you what we talked about before. And we talked about naphthalene. It was just like two benzene rings attached with each other. But naphthalene is actually the parent compound of a series of compounds that we named them fused polycyclic hydrocarbons. And in general, if you see like PAH in different articles or in news, these mean polycyclic aromatic hydrocarbons. So this is just abbreviation. And here your book also included the name of these. I'm not going to ask you, so that's why I didn't even include them here. But no, I can give you this structure and I say what type of compound this is. And I say fused polycyclic hydrocarbon. I say alkene, alkane, alkadiene, or like, maybe I give, I don't know, count up 1, 2, 3, 4, 5, 6, 7. How do for instance, I say heptadiene. No. How do we do that if it's 7? So it was diene, or like triene, or like tetradiene. Maybe tetra is the closest one. Tetraene, I guess. So heptine, I don't know. I just come up with something, whether linguistically correct or wrong, because that would be wrong anyway. I don't have to stress too much about it. But what I'm saying is that in exam, I give you like wrong things in the options, as long as you study. And this is the thing I tell, my 101 class too. As long as they study, it's super easy. But when they don't study, it gets really confusing, right? So when it give you this in exam, I say what type of compound it is, and I say fused polycyclic hydrocarbon, that is really easy question, right? Is it? Is it not? How many say this is easy? Okay. Good. So this is all I asked you about this. Okay? And you should know that naphthalene is the parent compound. So I may give you this. I say, what is the parent compound? And I say methane, methane, I don't know, ethine, ethene. polycyclic aromatic. Okay. And you may have heard of graphite, right? So graphite is, one form of carbon, right? And we have that, like, not in this pen, of course, but in pencil that you use to write, we have like graphite, right? So it's nothing but this, they have like that structure, but it is only, carbon. And we have like these hexagonal structures, and then we have like, if you have like in the structure that I just showed you. Okay. And these thing here, I'm just gonna ask like true or false questions, or like conceptual questions, so you don't have to worry about drawing this structure or like what is the bond length and all that. Okay. And that's why I included the screenshot of your textbook too, so you have like the materials to study. I was including your book, right, or like writing myself so many texts in it. So go through these and then read this line by line. I try to just explain anything that needed explanation, but most of it is just like what I talked. This was this slide, the first slide, that I try to have like more pictures so it becomes more interesting. As I said, and I put it here. If we have like infinite extension of these rings that are arranged, they're like hexagonal, right? Each of them, and then if we have them infinitely extended, it would be one sheet of the graph. Okay. And here again you have like definition, but with chapter 7. Any question from chapter 5? So I'm going to skip stereoisomers because we talked about them somehow in the class, and I didn't talk too much about like the angles or like get different structures from each other because it would be difficult to visualize conceptually, or I don't know. I thought that maybe it's better that I talk about more group of carbon compounds or like organic compounds compared to talk about something that I gave you some idea before. And chapter 7 is chapter 6 about hydrocarbons, that they have halogens in their structure and addition and elimination reactions. So since and substitution and elimination. And since I kind of talked about compounds that they have halogens in their structure, so again, you have some sort of idea. So what I'm going to do, I'm going to start included about that. Before I go, start chapter 7 to talk about alcohols, phenols, and thiols. Okay. And hopefully I can attract you guys' attention with this chapter. The other time I was talking about in my 101 class, I was telling them what is the difference, what is liquid, solid, gas, and I was like, ethanol is a liquid, you can drink it, so it's kind of like more tangible example. And then I was like, shoot, there are 18, most of them. Like, no, you cannot drink it, don't drink it. Don't go say that, I said that you should drink alcohol, or you can. Don't do it. But anyway, so, and here I just copied and pasted the picture of your textbook to again attract your attention. Your book here mentioned, ethanol is obtained from like fermentation of, carbohydrates that are in some fruits, right? For instance, grapes is a conventional one, or like there are like different sorts of alcohols, right? Or like ethanol. And we're going to talk about, it's chapter 16 is like really big, ambitious. It's like ambitious of me to think that I'm going to cover chapter 16, but maybe I just like touch upon on that. So what we're going to do is to talk about what are alcohols, and what do you think, are alcohols? When I say alcohol, what do I mean? Exactly, they have OH groups. Okay. And the way that we name them, for most of the compounds, we have IUPAC name and common name. And for most part of our course, I didn't talk about common names because it's just like memorization, and I don't want you to just do more memorization as needed. But IUPAC names, since is like a system of naming compounds, asking that. Okay, so include the common names here as well, but you should worry about or study IUPAC names. Okay, so when you see the common name, you should know what it comes from or kind of like have an idea, but I'm going to ask you IUPAC names in the exam. And then we have alcohols, for instance, you may have heard of methanol, ethanol, right? And anyway, so what we do, we add the ending of ol. And you can remember ethanol, methanol. If you remember that those guys have OH and they are alcohol, you can use that as a baseline to name other compounds as well. So previously, when we had double bond and a substituent, what did we care about more in the name of naming carbons? Do I care about substituent more or where the double bond is? Double bond, right? We care more about multiple bonds. But this is not the case here. Here, we care more about the OH group. Okay, and I have like example in the next slide. So here, when we have like CH3, so this molecule before it was like CH4, right? That we eliminated this hydrogen and we added OH. Okay, so the name meth, right? That is kind of like, remember methane, ethane, propane, butane, pentane. So you should remember those. That how many number of, depending on how many number of carbons we have like that structure. So this is meth something, and then we should have like OL at the end, because that is like, so kind of like I just underlined everything that is written here. This is methanol, it's OL, this is METH. So we call that methanol. And can anyone tell me why didn't I call this one methanol? Exactly, I have one carbon. Can I have two methanol? I don't have two carbons, right? So anytime that there is no confusion, I don't put the number because there is no reason to put that. But if there can be confusion, I should put the name. For instance, one example that we had, and I gave that in your exam, I said which of the IUPAC names is not correct. And I gave you butane, ethane, ethine, propane. So all of these ones, they don't need number, but this one needs a number, okay? Because I can have double bond here, or I can have it here. Depending on where I have it, I have one butane or two butane, okay? So kind of like reviewing what we talked about before, but this is not relevant to what I'm talking here, so I'm gonna delete it. But this is the reason I don't say one methanol, because there's only one possibility. The same thing with ethanol. If you draw the structure, if you attach the OH here, again, these are, you can have one at a time, right? So if you just, rotate the structure, in your head, you get the same thing. That's why we don't write, we don't have one ethanol, two ethanol. There's just only one. Does that make sense? Good. And also these guys, this is methyl, right? You can call this methyl alcohol, or this one you have an ethyl group. You can call it ethyl alcohol. So the common names, you write the name of the alkyl and you use the word alcohol. Okay. So what about the next one here? Should I put, let me have like the expanded structural formula. Maybe I write it here. I have more space. Okay. So this is CH3, CH2, CH2, OH. Does it matter if I attach OH here or if I attach the OH here? Is this the same? Are these two structures? And I just wanted to save time and kind of demonstrate them on the same picture. but your book have them separately. So these two are different, right? So that's why we put a number, and you count the number of carbons, the same thing that we were doing before, like the main chain that has more number of carbons, and excuse me, we name them from the one that has the substituent, which is OH attached to it. So we reach OH soonest. So that's why this is 1 propanol. This is not 3 propanol. Okay, this is 2 propanol. And the common names are like N-propyl alcohol or isopropyl alcohol. Do you remember when I was talking about like butane, for instance? We said that we have butane, we have isobutane, we have like tert-butyl, sec-butyl, depending on the structure that we had. So this is kind of like similar story. And here we have 1 butanol, 2 butanol, 2 methyl. So let me just talk about this real quick when I still have some time. So CH3OH, right? So again, we care about the OH more. So we start 1, 2, 3. So this one, how many carbons we have? 3. So it would be propa, and then we use OL for alcohol. So this is propanol. Propanol, okay? And it's attached to carbon number 1, but you should name your methyl too, right? So that is 2 methyl. So this part is the same. This part, you should remember that we have OL for alcohol, and then depending on number of carbons. And then you have another example here, and some examples here too. So I asked you to study the slides, till the end. And then next session, I'm going to talk about this ugly name here, 2-propene, 1-ol. So kind of like review them. And as I emphasized, basically if you have like unsaturated structures, this is how we do it. We separate all with the number. And here also, you can kind of like based on carbocations that we studied before, kind of see the classification of alcohols as well. So this is like fairly straightforward too. And then phenol, we also talked about, which is like OH attached to a benzene ring, okay? And the nomenclature is also similar, but I also want you to know what was benzyl, and these ones you're gonna see on your homework this weekend. So remember phenyl, benzyl. But the last slides about phenols, and included these 2 slides for